Welcome back, everybody. This is the final part. We have 2 more questions to go over. Your actual test tomorrow that you'll be taking will have, I believe, 12 questions on it. This one only has 11. The height of a maple tree is recorded for each of the 5 years in the table shown below. So there's the table. Chris displays the circle graph, all the data in a circle graph. Here's the question. Notice first that it is a 4-point response. Usually means you got to do how many things? 4 things. Emily, how about explain why Chris's circle graph is not appropriate? That's the first thing you got to do. You got to explain why it's not appropriate way. Create and label. That's the second thing you got to do. Create and label an appropriate graph. So you're going to make your own graph. Be sure to give your graph a title, labels, and scales. There's the third thing you have to do. And the fourth thing you got to do is tell me why your graph is a much better way. So, a couple of different ways we can go about solving this. You can actually write sentences. So, okay, well, number 1, I need to explain why Chris's graph is not right. Why is Chris' graph or Chris' data graph not a good way to show the data of the tree growth? Anna Grunick, you got to be loud. Because somebody might not look at the tree and be able to tell how tall it is. All I can see in this data, that's a pretty good response. All I can see is that in year 1, it grew about that much. And in year 2, it grew a little bit more than that much. Okay, but I don't know how much that is, right? What do circle graphs really give us good information for? Andrew, percentages. Do we see any percentages up here? So that would be 1 or 2 of my reasons as to why his graph isn't right. It does not show percentages. Not only that, but I can't give detail about growth. So I look at that graph. All I can see is I know it's bigger in year 2 than it was in year 1, but I don't know how much. I could estimate, but that's not what we're asked to do. The second thing is to create and label an appropriate graph. That would be a better graph to do this. And as I recall, most of you guys were able to do this. What kind of graph are we going to make? Heidi, what kind of graph you want to make? Bar graph. I like bar graphs. I think they're easy to do. So we would make a bar graph. And your bar graph would look something like that. You'd have to give it a title. Tree height. I'd have to label my axes, year, and growth in feet, right? Growth. And I believe I had, year 1, year 2, year 3. How many years did it go up? 5? Yeah, 5 years, 3, 4, and 5. And then my highest number was 14, correct? So we might do this as 2, 4, 6, 8, 10, 12, and 14 would be way up here. So I'm off just a little bit. But you get to see what I'm doing here, right? How tall was it in year 1? It only grew 4 feet. How about in year 2? 6 feet. And then 9 feet. Hang on. 9 feet's right about there. And then we had 13. 13 was right about here. And last but not least, we had 14. That one goes all the way up to the top. So now we've drawn our graph, right? So we did this one. We drew our graph. We labeled everything. Check that one off. There's number 2. Number 3 was labeling everything. So we did that. There's number 3. And number 4 is explain why is a bar graph a better choice. Why is a bar graph a better choice? Michael, don't tell me it's easier to read. That's too simple. Yep. A bar graph would be a better choice because it shows actual growth. It's going to show actual growth. It's a much better choice because it demonstrates or shows actual growth. I can look at these bars here and really see how tall each one of them got in each year. I can see the difference. Would tell me how high it is from year to year. So we did a really nice job there. RJ, do you got a question? A line graph's not a bad choice either. Line graph's not a bad choice either, okay? See, if you did a line graph, it's a lot like a bar graph. I'd be willing to bet, RJ, your line graph just has lines that connects each of these. So it shows you maybe the rate of each growth, okay? You can calculate the slope of those lines and figure out how fast it grew from one year to the next. Ava. X's are line plots. Line plots are similar to bar graphs, but line plots actually would tell us how many people voted for something. Because each X then represents a choice. Wouldn't be for this one. Okay, some of you made bar graphs, but you filled them in with X's. So it looked more like a bar graph, and I'd be okay with that. All right, let's take a look at the last question down here. Okay, whoops. Let's erase this here so we have some room. Section 3 says review 54.2 times 1.7. Multiplying decimals. Multiplying decimals. Who can multiply decimals for me? That's it? Only 4 of you? All right, Andrew, come on up. Multiply that decimal for me. Show me what you're doing. Yes, just the same thing as just regular. You do it up here in the boxes. 54.2 times 1 7/10. Now, let me ask you this question before you start. Is it really important when you're multiplying decimals to line up the decimals? No. When you only line up decimals when you add and subtract. The important thing when you're multiplying decimals, can I borrow that? Is to line up the digits. Forget the decimals are even there. Line up the digits. If you don't line up the digits, you're going to be totally off. Okay, so on your test, if it were maybe 54 2/10 times, I don't know, 20. Maybe it was 20 instead of 1.7. The 20 would go here and here. Don't line up your decimals, then you line up your digits. Line up the digits. Now multiply. Yep. 2 times 7 is 14. 7 times 4, 28. Plus 1 is 29. 37. Now what? Nope, you don't need to put the decimal. You do need to put something right here. Why a 0? You got it. You move over in the tens. You got to put a placeholder in. Now you just multiply. 1 times 2, 1 times 4, 1 times 5. Now you're going to add them up. Let's add them all up. I like the little mustache thing. That was kind of nice. Styling and profiling. I appreciate that. Excellent. So what's your answer? Not 9,000. What should it be? How many decimal places do you see over here? 1 here and 1 here, right? For a total of how much? Total of 2. You take your decimal right here and you go 1 place, 2 place, and you put your decimal in. And I heard people go, oh, yeah, that's kind of right. Nice job, Andrew. Everybody give Andrew a round of applause. All right. Now, is there another way to solve this problem? Matthew, what is it? Lattice multiplication. I love lattice. 5 here, 4 here, 2 here, and a 1 here, a decimal point, and a 7. It's not a 4, it's a 7. I know what I'm doing. Draw your lattice boxes. Try and be neat about it, not sloppily. And now we multiply 1 times 2. 2 there, 0 here. 1 times 4. God bless you. 4 here, 0 here. 1 times 5. 5 here, 0 here. 2 times 7. 14. 7 times 4. 28. 7 times 5. 35. And now we got to add. That's a 4. 8 and 2. Oh, 8 and 2 is 10. Plus 1 is 11. Carry your 1. 5 and 4. Plus 1. Plus 2. Put your 2 down. Carry your 1. 5 and 1. Plus 3. 9. 5 and 1 is 7. Or 6. Plus 3 is 9. Now watch. For all my decimal lovers. There's the decimal. There's the decimal. Here, here, and kick out. 92 and 1400ths. Same exact answer. Well done. Hope you guys enjoyed the review. Everybody say good night now, Mr. Lowe. Good night now, Mr. Lowe. Well done.